Okay, good afternoon all. I welcome you all for this today's session. Now, in today's session, we are going to discuss the processing method for the thermosetting plastic materials. Okay, just I will take a review of the previous session, and then we will start the today's session. Okay, in the previous session, we have completed the blow molding process. Okay, only one molding process we have discussed, that is blow molding process. And basically this blow molding process is used for manufacturing of the hollow components, okay, like your plastic bottles and plastic small tanks, you can say storage tanks, then pipes, then different household products, then air ducts, which is used in the automobile. Okay, then we have discussed the basic principle, or you can say the steps involved in the blow molding process. It consists of, first step will be preparation of the parison, or this parison is also termed as the preform. Then we are placing it in between the two half of the molds. This is the first step. Then we are closing that mold in the second step, and in the third step, as that parison or preform has one opening at the top end, through that top end we are blowing it with the help of air or compressed air. And due to this, what will happen, that parison or whichever material of that parison is there, it will get pressed against the walls of the mold cavity, and it will acquire the desired shape and size. And we will wait here for some time, or some time is provided for the cooling. Okay, and after sufficient cooling, we are removing that mold, and that part is ejected, okay, from that mold cavity, and final component is obtained. sorry sorry for disturbance. Okay, finally we will get the desired product. Now in this blow molding process, some kind of flash or pinch off may be there. Okay, flash is nothing but the some extra material may get attached to your product, okay, like this. So for removing that extra material, we require some finishing operation, and finally we will get the desired component. Now this blow molding process are basically classified in three different types: extrusion blow molding, then injection blow molding, and stretch blow molding process. And these three types are further subdivided in, or there are two subtypes for each type, okay, like continuous and intermittent, or single stage and two stage. Now the single stage blow molding process means whichever preparation of the parison, then placing it in the mold, then blowing the air and cooling, all these processes will occur on a single machine. That will be termed as single stage blow molding process, or you can say the continuous blow molding process. Okay, now according to the types, we have discussed their working principle. Injection blow molding process, that parison is prepared by injection molding process, and then a regular blow molding operation will occur. Then in the extrusion blow molding process, whichever parison is required, it is prepared by extrusion process, and remaining will be the same process as we are following in the simple blow molding process. Then in the stretch blow molding process, here some stages are different. Means parison is prepared, then whichever parison or preform is there, it is preheated, and after that it is stretched by controlled amount of air, and then the full air is blown. Okay, this is the full blowing, this is the stretching or pre-blowing. Okay, and the remaining steps will be same. Then these are some applications of blow molding process, different toys which are hollow. Then your cold drink bottles or water bottles. Okay, then different storage tanks or water storage jars are there. Then cosmetic bottles of tubes. Okay, then these are pharmacy PEC bottles, pharmacy, where we are storing the medicines or syrup. Okay, then these are storage tanks. The small capsule bottles are also there. Okay, these are the different cosmetic packagings. Okay. So these are some advantages and disadvantages. In disadvantages, you can highlight that we can only manufacture the hollow component here, and some kind of defects like flash may be there. And then in advantages, you can say the cost of tooling is less and fast production rate. Then you can do the recycling of the material. Okay, whichever processes are there, like injection molding process, extrusion molding process, means the processing methods which we are using for thermoplastic materials, we can do the recycling of that material. But in case of thermosetting plastic materials, we cannot do the recycling. We cannot do the recycling. Okay, is it clear? Then after this, we will move towards the now in today's session, we are going to discuss this part, that is the processing of thermosetting plastic materials. Okay, now already we have discussed that what is the difference between thermoplastic material and thermosetting plastic material. Okay, in case of thermoplastic material, in case of thermoplastic material, we have seen that whenever we provide heat to thermoplastic material, it will start melting and we can give the desired shape, and after cooling it will become hard, and we can repeat this process again and again. Means whichever process we are conducting on the thermoplastic material, it is reversible. We can do it again and again. But in case of thermosetting plastic materials, how we are going to give shape to them? Whenever we provide heat and pressure, it will get cured. Cured means it will acquire the whichever shape you want to give, or whichever cavity you will provide, mold cavity, according to that it will acquire the shape. But in case of thermosetting plastic material, you can do this process only once. This process is not reversible, or you cannot do the reshaping of thermosetting material again and again, like in case of thermoplastic materials. Okay, thermoplastic material means our polyethylene or polypropylene, or simply you can see that our whichever plastic bottles we are using, we are recycling it, we are using it again and again. But whichever thermosetting materials are there, for example, thermosetting material, you can take the example of these switchboards, the plastic part. Okay, you can see here this part. This is made up of bakelite. Okay, and it is a thermosetting material. It is very difficult to recycle. Are you getting this? And how we are going to give them shape to that thermosetting material? Mold cavity will be there. Then that raw material will be taken in that mold cavity, and we will provide some heat. Preheating will be done, and pressure will be applied. Okay, that mold will be in the heating state only, and simultaneously we are applying the force or pressure, and due to that force or pressure, it will acquire the shape and it will get cured. Cured means it will get solidified. In simple words, whichever mold cavity you are using, that shape it will acquire, and after some time, if you remove the that force, you will get your final product. Some finishing may be required, but it will acquire the shape and size of that mold cavity. Okay, this is the thermosetting material, and you cannot reverse this process, or you cannot do it again and again. Getting this means whichever thermosetting materials are there, we cannot do the recycling of that. Recycling of that material is not possible. That is the disadvantage. You can write in compression molding, transfer molding, or rotational molding. We cannot do the recycling of the material. Okay. So in simple words, I have explained it, and all these points I have highlighted in this slide also. I will go through it. Thermosetting plastics cures after heating and sufficient strength is developed. Okay. Then thermoset molding process is irreversible molding process. Okay, by which malleable forms of plastics are forced into a heated mold and formed into their final shape by applying some external force. Okay, but in case of thermoplastic molding process, it is reverse process or a reversible process. It is not the word exact word reverse. It is a reversible process where the material is heated and it is injected. Suppose, for example, in case of injection molding, it is injected in the cool mold, or where mold is there and we are providing the cooling. Then material is cooled to get the final shape. Okay, what we have to remember here, very important point is, in thermoplastic material, we are heating the material. It will become a little soft, or it will go in the pasty form, and then we are providing them or inserting them into the mold cavity, and we are cooling it. After that, we will get the final product after its solidification. But in case of thermosetting plastic material, in the heated mold, we are heated mold. In that heated mold, we are taking the raw material. That raw material is termed as the charge. That material whichever we are collecting or taking, it will be termed as charge, and we are applying the pressure. In case of thermoplastic material, that mold is supplied with the cooling channels, but that is not the case in case of thermosetting material. That mold is heated mold, and in that we are placing the charge and the force is applied. Okay, and when we remove the force, it will get cured. We are not cooling it. Please remember this. We are not providing any cooling operation in thermosetting processes or processing of thermosetting materials. Just heated mold will be there, material will be placed, and force will be applied, and some time will be given. Then it will get cured. This will be termed as curing process. Okay, and in this we are going to study three different types. The first type is compression molding process. Second type is transfer molding process. And third type is rotational molding process. In today's session, we are going to discuss first two types. Okay, compression molding and transfer molding process. So we will start with the compression molding process. Okay, here I have given some steps, not steps. I think I have not highlighted the steps here. I have given some general information related to the compression molding process and the steps added in this diagram. Okay, so this diagram we will discuss the steps. Okay, just I will go through it, and after that, just read it properly, and the working principle I will explain here with the help of this diagram. Okay, now this compression molding is one of the forming process. Means whichever raw material is available, we are converting it into the desired shape and size or in the usable form. Now, this compression molding process, basically it consists of only two steps. Okay, while performing that operation, I have divided that in the 4 parts for easy understanding. But basically, only 2 steps will be there. That the first step is preheating of the charge or raw material, and second step is the pressing or pressurizing. Only basic two steps are there. But for better understanding, I have divided that in the 4 steps that I will explain it later. But basically, compression molding process consists of only 2 steps. In the first step, we are doing the preheating. Whose preheating we are doing here? Charge. And what is the charge? Charge is nothing but your raw material. Charge is nothing but your raw material, and its preheating is done. And we are applying some force. It will be termed as pressing or pressurizing operation. Okay. Now, in the next part, you can see here major charge of a compound. It's placed between the two halves of the split mold. Then pressure is applied so that compound flows to fill the mold cavity. That I will explain with the help of diagram. Okay, all points I will explain with the help of diagram. Just try to understand few examples of the materials here. Here I have highlighted few materials: urea formaldehyde, phenol formaldehyde. These are thermosetting plastic materials. Okay. Now, please go through this point. This is the application. Different types of dinnerwares are there. In dinnerware, your dishes are there, dish and plate, or different kinds of trays. And in your kitchen, you may have seen these products. Then different knobs or buttons of your shirts. Okay, it is manufactured with the help of compression molding process only. Whichever buttons are there on your fabric or your shirts, these are manufactured with the help of this process. Then radio cases, then different electrical parts. That switchboard, I have already shown you this switchboard, where or that switches. Okay, that switch board means this portion, this switches and this plug, where we are putting that plug, that socket. It is manufactured with the help of this compression molding process. Then automotive exterior panels. In this exterior panels, outside body parts like bumpers. Okay, it is manufactured with the help of compression molding process. And these are commonly used materials. Okay, urea formaldehyde, phenol formaldehyde, then polyurethane, then unsaturated polyesters, then phenolics or silicones. These are different examples of the materials. These are materials. Now, these are some basic parameters that will affect the compression molding process. The first parameter will be quantity of your charge. Quantity of your charge means quantity of your raw material. Then amount of pressure, then temperature, and the cure time. What is the meaning of cure time or curing time? Okay. Okay, when initially we are preheating the charge, and after application of the pressure, that mold cavity, we are heating it. Okay, why we are heating it, that I will explain in this point. Why we are heating the mold cavity. In thermoplastic material, what we have seen, basically thermoplastic materials are formed by the, you can say that, addition polymerization. Okay, we have discussed the polymerization process. Means no byproduct is formed, but in thermosetting plastic materials, their polymerization occurs by formation of some byproducts. Okay, here also when we are pressing it, some byproducts will get released. Okay, that's why that mold is heated. Okay, to eliminate that byproducts. That mold is heated. Suppose some acid or some water is formed, it will get eliminated, and this polymerization process will get completed. In simple word, time required to complete that polymerization process with application of some force is termed as the cure time or curing time. Are you getting this? Okay. Why we are providing or using the heated mold cavity? Why we are providing the heat into the mold cavity in thermosetting processing methods? Because in that polymerization process, some byproducts will get released, and to eliminate that, we have to provide the heat. And when it will get eliminated, automatically that polymerization process is completed. And that material will become hard. Okay, it will become hard. Here that word is mentioned. Okay, the time period required to harden the thermosetting material to partially or completely finish the polymerization process is termed as the cure time. Okay, and basically this cure time varies in the range of 1 to 5 minutes depending on the different materials. Now, these are some important points that you have to consider or keep in the mind while performing or before starting the compression molding process. Automatically, you will be able to write this point when you understand the basic principle. Okay, just means how to select the proper amount of the material, then amount of energy required or heat required. Okay, then time required, then which technique you are going to use to provide the heat, then amount of pressure or force required, and how we are going to do the designing of the mold. All these parameters you will be able to or you have to decide before starting the process. This is not the part of your syllabus, just I have added for your information. Now we will move towards the main part here. Okay, so this is the compression molding process. Please listen it carefully. This is compression molding process. Now this is the mold which is divided in two parts or two halves. Okay, this is the lower half of the mold and this is the upper half of the mold. Okay, lower half of the mold is fixed. It is fixed, and upper half of the mold is movable. Here in bracket I have mentioned it. Upper half of the mold is movable and lower half of the mold is fixed. Now the movement of this upper half of the mold, we are doing it with the help of guide pin. Okay, here in this place we are hitting the guide pin, and with the help of that guide pins we are moving it. Okay, now in the lower half of the mold we are putting or taking the charge. This charge is nothing but the raw material. Okay, or raw material to which we have done some preheating. That is the charge. Okay, are you getting this? Then we are applying the pressure with the help of this upper half of the mold by using, and we are moving it with the help of guide pin. Okay, this is the pressing stage, and when pressure is given, you can see here it is acquiring the shape. This is the charge. It will acquire the shape of this mold cavity. Okay, is it clear? Then after some time we are removing this or we are releasing the force, and this lower half of the mold is heated. Okay, we are providing heating here. Then after pressing we are providing sufficient time, and then we are removing this upper half also, and with the help of this ejector pin. Okay, this is raised in upward direction, and whichever part is manufactured, it is removed from that mold cavity. In this way this compression molding process takes place. In second slide I have increased that steps. Okay, so these are two half of the mold or two parts of the mold, upper part and lower part. Lower part is fixed. Okay, this is the charge or your raw material. First, initially what you have to do, loading of the charge is done. Then in second stage, okay, this charge before loading already we have performed some preheating. Okay. Then we are loading it here, and then force is applied with the help of this upper mold part. It is also termed as punch. Okay. And this lower mold part is means simultaneously we are doing the heating there, and pressure is applied here. Okay. Now in this stage, what will happen due to this pressure? Whichever shape we have given to this mold cavity, that shape will be acquired by that charge, and it will get cured. And when then punch is removed, or upper half of that mold is removed, and with the help of this ejector pin or knockout pin, this is also termed as ejector pin or knockout pin, here name is given, and we are taking this part. This is our final product. This whichever colored portion is shown here, this is the molded part or our final product. Again, I have added some products here so that you will understand. Okay, this is the example of the manufacturing of the flower pot, how it is manufactured. Okay, initially charge will be there, it is not having any shape. Then this is the mold cavity having the desired shape. Okay, initially we are just taking the charge, then pressure is applied, then it is removed, and finally the component is ejected with the help of ejector pin or knockout pin, and this is your final product, flower pot. Okay, this is the compression molding process. If you are having any doubts, please ask me. Which these are, we are generally using steel mold, na mold it will be made up of metal. No, it will get means as it is thermosetting material, it will get removed. It is thermosetting material. Or sometimes you can attach some lubricants there to that surface. Any other question? Okay. You can draw this diagram, any one diagram for your understanding. This one or this one. Please draw any one diagram. Which one is better? This one or previous one? Previous one. Please draw this diagram. I will wait for 1 minute here. Okay, then we will move towards next point. That is the advantages of compression molding process. Now, internal stresses are very less or minimum in this case. Okay, internal stresses are minimum. Why internal stresses are minimum? Why internal stresses are minimum here? Because why internal stresses are minimum? Because we are here in the mold, we are providing heating due to pressure. Simultaneously heating is also there and pressing is done. Hence, whichever stresses are there, it will get released. Internal stresses are released continuously. Hence, you can say that internal stresses are minimum. Then warping is very minimum. Warping means sometimes your component will get bent. Okay, it will get bent or other than whichever shape of that mold cavity, some extensions may be there. That will be termed as warping, and it is very less in this case. Okay, then in this arrangement, as very much similar to your number of processing methods, some runners, screws, or gates are required, but in this case, no such arrangement is required. Okay, directly in mold cavity, we are taking the charge and applying the pressure. Okay, for transferring that raw material, no medium or any tool is used in this case. That's why you can say that no gates, screws, or runners are there. Means it will it will decrease the cost. Your tooling cost or material cost is there, it will be reduced. That is mentioned in this case here, lower cost of tooling. Okay, then it is very good for small production runs. And then large sized components can be easily manufactured. Okay, outer body parts of your vehicles, they are large in size, and all these parts are manufactured by this compression molding process. Okay, we are using compression molding process here. Then what are the disadvantages? Wastage of the material will occur. Wastage of the material, as we are pressing it, some material may get removed or wasted, okay, from that die cavity due to the sudden application of that pressure. Means wastage of material is very high. And then labor cost is also high, because here skilled workers are required. Okay, this is a very risky operation. Okay, that's why skilled workers are required. Then the processing time is very high, because curing will require some time. Curing of that plastic raw material will take some time. That's why as curing time is high, automatically that processing time will be increased. Hence, you can say that this compression molding process is time-consuming process. It will take some time. Then complex shaped components cannot be manufactured. If intricate or complicated shapes are there, we cannot manufacture it. You can see that whichever outer body part of your vehicles are there, that are simple in design or simple in shape. That's why we can use the compression molding process. Otherwise, if complex shapes are there, then we have to go for other process. And that method is nothing but your transfer molding process. Okay. Then some defects may be there, like the flash. Okay, some extra material will be there other than the part design. Some extra material may get attached there. That is nothing but your flash, or you can say that flashing will occur, and it is removed by some machining operation. Okay. Then sometimes uneven parting line, these kind of defects may be there. Then whichever molds we are using, okay, this is your mold, okay, and continuously we are applying the pressure, means in between these two parts of the mold, wear will there, wear and tear, means we are applying the force, okay, means friction will occur between two parts and some material loss may be there or some damage may occur. That is nothing but these molds can be subjected to wear and tear due to repetitive action or this pressing operation. Then whichever scrap is produced, that cannot be recycled or reprocessed. As it is a thermosetting material, we cannot do the recycling or reprocessing of that material. Okay. This is the flashing. Already have explained it. Upon removal, it's quite common that molded product to contain some excess material, it is termed as flashing. Okay. And it is removed by some experienced cleaning team by performing some operations, finishing operations. Okay. So these are some applications of compression molding process or different plastic components manufactured. Okay. This is the energy meter casing. Okay. Then mirror body. This is electrical receptacles. Okay, here we are fixing our chargers or whichever accessories we are using. Then these are the plates made up of plastic, and these are the buttons. Then your hairbrush handle. Okay, all these are manufactured with the help of compression molding process. Then these are different trays of the plastics. This is dinnerware set. Okay, this plate, then this bowl or dish, you can say. Then different kinds of spoons are there. Then the plastic tires is also manufactured. Okay, some part may get repeated. Dinnerware, buttons, knobs, or home appliances. Okay, outer body parts of the vehicles. Okay, these are also manufactured. This is manufactured with the help of compression molding, this part, outer body part. Okay. Now the next step or next type is transfer molding process. Okay, I will try to complete it within 10-15 minutes. Okay, I will repeat this again in next session also. Okay, I will just take the basic concept. Okay. Now, where this transfer molding process is used, as in compression molding, we have discussed in the disadvantages. We cannot manufacture the complex or intricate shaped parts. Means thermosetting material, we cannot give them intricate shape. Here, that intricate shapes means your bathroom fixtures. Okay, bathroom fixtures that can be manufactured with the help of this transfer molding process, or these turbine blades also can be manufactured. Then your boat hulls or different parts in your aircrafts. Okay, all these can be manufactured with the help of transfer molding process. Now, in this transfer molding process, okay. So this is the description related to this transfer molding process. You can go through it. I will explain with the help of diagram. All that points will be here only. Steps will be mentioned. Now, okay, this is the working principle diagram. So initially, Here also you can say that this is the upper part will act as a plunger. And here one cylinder or a pot is given. In this cylinder or transfer pot, the charge or a preheated raw material is collected. Okay, or it is placed. Preheated raw material, which is also known as charge. Now the preheating is done in between the temperature range 150 to 175 degrees Celsius. Okay, then it is placed in this transfer pot. Okay, this is the transfer pot or a cylinder, you can say. Then what will happen in the next stage? In the second stage, with the help of this plunger, we are applying the pressure. Okay, we are applying the pressure on this charge. As some preheating is done, you can say that it will move, or that material is little plasticized. It will get moved through this screw and it will enter in this mold cavity. Okay, and whichever heating is required, that heating is done with the help of these heaters. Heaters are there. With the help of these heaters, heating is done. Okay, I will repeat it again. Initially, we will take the charge in the transfer pot. Okay, that charge is preheated at 150 to 175 degrees Celsius, and then in the next stage, pressure is applied with the help of this plunger. Then, due to application of this pressure, that material will get transferred from this screw and it will enter into the mold cavity. And here again, heating is going on with the help of these heaters. Okay, then sufficient time is provided, and during this time, that material will get cured and it will acquire the shape of that mold cavity. Then this plunger is removed and this mold is opened, and whichever part is there, this final part, it is taken out with the help of this ejector pin. Okay, with the help of these ejector pins, that final component is taken out. Okay, now in this transfer molding process, it may be single cavity or multi-cavity transfer molding process. Okay, this is single cavity. Here, single cavity will be there, or this is your molded part. Okay, here I have highlighted it, multi-cavity transfer molding process. Okay, here your charge will be taken. This is your heated mold. Mold is heated. Please keep in mind that in compression molding, transfer molding, or during the thermosetting material processing, whichever mold we are using, it is heated. In case of thermoplasting, we are cooling it, but here we are heating it. Okay, now material is taken or charge is taken here, and mold is heated. Then pressure is applied with the help of this plunger. Then it will flow through this screw and it will enter into these cavities. Okay, then after some time it will get cured. We are not providing any cooling channel. Automatically it will get cured. And after some time, we are opening this mold. From this point, it will be opened and these parts will be collected by raising these ejector pins. Okay, these are ejector pins. By raising these ejector pins, this is the part. Molded part is removed from this mold. This is the transfer molding process. What is the difference between compression and transfer molding process? All processes are similar. We are taking the charge, preheated charge, then applying the pressure, simultaneously heating is going on, and due to application of pressure, that material will acquire the shape of that mold cavity, and after some time, curing will get completed, and we are removing that part with the help of ejector pin. Process is same. Just in transfer molding, initially we are collecting the charge in a transfer pot or cylinder, and it is transferred through the screw arrangement. Through the screw, we are transferring it into the cavities. In case of compression molding, we are not doing any transfer. At that spot only we are compressing it or applying the pressure. But here we are transferring that charge with the help of screw into the cavity to get the desired product. Okay, this is the basic difference. And this is the transfer molding process. Now transfer molding process has different types. Here, this is the depending on the use of cavities, single cavity transfer molding process, and this is multi-cavity transfer molding process. And some other types are there that we are going to discuss in our 4th or 5th chapter. Some extra types are there that we will complete there. Okay. Now here try to remember the basic principle and the difference between compression and transfer molding process. Now, as we have modified this in compression molding process, we perform some modification. We are using here some screw and a transfer pod. And due to this modification, some advantages we will get. What advantages will be there? Here in transfer molding process, we can manufacture some intricate or complex shapes that are not possible in compression molding. We cannot manufacture complex shapes. Here in transfer molding process, we can manufacture the complex or intricate shapes. Okay. Then whichever, these are the advantages. You can go through that. I'll complete it. I'll repeat this part again in the next session. Now time is about to over. I will repeat, or I will take it in short way. The next session, again I will repeat this part. Okay. So whichever setup cost is there or processing time is there, it is very less as compared to compression molding process. Then design flexibility will be there, as we can manufacture complex parts or complicated shapes. Then multiple cavities can be used, hence yield will be high or production rate will be more. Then flash is not available or flash is not produced in the finished component. Flash is not produced, but wastage will be there. In this process also wastage of material will occur. Okay, can you tell me where wastage of material will occur? Wastage. Whichever screw or this runner arrangement we are using, here whichever material will left here, that will be waste material. Okay, means we are not able to eliminate the wastage in this case or in this type also. Okay, but flash is removed. Flash means extra material attached to the final product. It is removed, but wastage of material is not removed. Then a lower cost due to simple pot and plunger design. Then short processing time. Uniform thickness can be obtained. Okay. Uniform thickness, dimensional accuracy will be high. Maintenance cost is less. Okay, tool maintenance cost is less in case of transfer molding process, but tool maintenance cost is high in compression molding, because we are pressing that mold is applying the pressure continuous. Due to continuous pressing, wear and tear is there. Hence, continuous loss of that mold material will occur and continuous maintenance will be there. Okay, so here we can do the complex designs, but it will increase the cost as we are using complex molds. Then it will increase the maintenance cost. Then due to that screw, scrap will be increased. Okay. Then again, scrap cannot be recycled or reprocessed. Then the overall operation could be cumbersome, as each charge is loaded manually. Cumbersome means some hectic work is there. Okay, for the operator, it will become some hectic operation. Then air can get trapped in the mold. Then high pressure is required. And if you compare this with the injection molding process, its production rate is low as compared to injection molding process, but it is faster than the compression molding process. Okay. Then this transfer molding process can be used in different industries. Here I have highlighted some components: bath fixtures, bathroom fixtures, then wind turbine blades, boat hulls, different aircraft parts. Then this is the helmet. Okay. Then some automobile parts. These are also some bathroom fixtures. Okay. Okay, in this way, we have completed this. In this today's session, we have completed the compression molding process and transfer molding process with their working principle, then advantages, disadvantages, and applications. In next lecture, we will discuss the rotational molding process and some part of this transfer molding process. I will repeat again. Okay. Please, those who are attending lecture through online mode, please enter your roll number in the chat box for your attendance purpose, and you can leave this session. Okay, please roll numbers for attendance. 14, 66. Wait. Okay, I will stop this session here only. Thank you for attending this session. You can leave now.